As an AI-first company, we specialize in deploying massive infrastructure projects, primarily focused on GPU infrastructure, which requires the highest level of power and next-generation cooling that's available. From the architectural perspective, we interface between all of our teams and the customer to ensure that we're sizing storage correctly, networking correctly, and that we're co-engineering to meet their specific product and workload. Our teams bring together GPU, networking, cooling, power. We bring together all of our experts to define what a scalable unit is. And a scalable unit can range in 200 GPUs up to 1,000 GPUs or many thousand GPUs. And that is how we start to lay out a data hall. As we progress in next generation hardware, we expect to see GPU and networking become more tightly integrated. We expect to see more GPUs and more power per cabinet. As things get very close together, you have to increase the cooling capacity by moving to a water-based solution. So liquid cooling can reduce about 4 times more temperature, which means we can reduce the footprint, we can go more dense in the cabinet, and by going more dense we can have shorter distances for communication, which shortens the latency, and altogether we're able to get a lot more GPUs in a denser footprint. The network type defines how many racks can be grouped together. For instance, in the Hopper generation, a scalable unit was 256 GPUs. Now with higher radix switches, we are connecting 576 GPUs up to 1,000 before we need to expand and add a core network. So in that physical layout, if I need to add a core network, I could be adding 18 or all the way up to 70 some racks, which reduces the total amount of power for GPUs. When you're working with massive data centers that have hundreds of megawatts of power, adopting CPO technology allows us to add hundreds to thousands of GPUs that we wouldn't have been able to. Adopting CPO equals more GPUs equals faster time to solution for our customer. It's very important for Lambda to deliver fully qualified clusters on time. Once the full cluster has been evaluated for the basic things like GPUs are healthy, CPUs are healthy, nickel's healthy, then we run an ML training workload and ensure that we can scale from, say, 1 GPU up to tens of thousands of GPUs. We manage and operate everything from infrastructure to GPU cloud. We are Lambda, the superintelligence cloud.